All right, here we go. We are reviewing for this Chapter 7 test. So here's a quiz you just got back. And let's go through some. Number 1 shouldn't be an issue, right? Number 2, it's you just didn't realize what formula you're supposed to use. And I think on the review, didn't I tell you that 2, 3, and well, at least 2 and 3, right? You're going to use particular formula. Yeah. Same with 5. Number 4, you don't really need that formula. What is the formula that I'm talking about? Area of a regular polygon. Good. It's 1/2 AP. What is the A? It's the apothem. What is P? It's the perimeter. What's the apothem? On number 2, what's the apothem? No, what's the apothem? Give me a number. It's 4. It's 4 right there. That's the apothem. Okay, from the center, perpendicular to one of the sides. Look, what's this apothem? 29. What's this apothem? Now, you could have done this a couple ways, but really all the other ones. What's the apothem here? Don't know just yet. It's the dotted line, though, isn't it? Okay? All right. We'll talk about that when we get to it. So that's basically all you do. But what's the perimeter? They don't give you the perimeter, but how do you find the perimeter of this number 2?
13.9 times 30.
Yeah, that's it. And that's like, I'm looking at my thing. It's 41.7. Multiply by the apothem, which is 4. Take half of it. So half of 4 is 2. 2 times, what did I say? 41.7 is 83.4. So I wrote the answers down for you. I'll write it down now. Might as well. I'm right here. So 83.4. It is in feet, so it's what? Feet squared. It's not units squared. Why don't you just write units squared? Because it tells you it's feet. That's exactly right. Okay, they tell you it's feet. Don't put units. All right. Luckily, I'm not marking those wrong. Okay, I could. Teachers do. I've had teachers that did that. Okay, and I think when I was a kid, I probably said, if I was ever a teacher, I used to do that a lot. If I was a teacher, I would do this, I would do that. You know, you ever do that? So I remember doing this. I'm like, I would never mark a kid's test wrong or a quiz wrong if they didn't put the correct units. All right, some do though, but I still don't. I've never marked off for that, and I won't. But you still should know it, because if you go somewhere else to another teacher or another school or whatever the case is, you need to make sure you get the units right. Number 3, basically same thing, right? Same thing, different numbers. But what do you do? 24 times what? 1, 2, 3, 4, 5, 6, 7, 8. So 24 times 8 times 29, whatever that is. Take half of it, right? There's your formula. And you get a big old number, 2784. 2784 when you do all that stuff. Just using calculator. You could do this a couple ways. You could go, well, you don't really know the side of it, but if you did know the side, it was actually an easier way than going 1/2 AP. What would that be? Right, if this is 5, what is it from here to here? That's 5, so what's this whole thing? That's 10. What is it from here? It's also 10, okay? All right? And then because it's a regular, right? It's a regular polygon, so which means it's a what? It's a square, correct? You guys listening? So it's 10 times 10 is what? 100, just like that. It's inches, so it's what? Inches squared. Just made a big deal about the units, and I didn't put the units down. What are the units on this one? Centimeters square, because it's what? Area. There's a problem where it says circumference, and I had a couple people put whatever the units, inches squared. Is circumference inches squared? No. Circumference is the distance around the thing, correct? All right, it's just the length of it, all right? It's not squared. Only use squared when it's what? Area. Okay, number 5. Let's take a look at this one. This is a little more difficult. All right, so let's take a look. How many sides does this thing have? 6. It's a hexagon. All right, so what we're going to do is this. They don't give you anything inside of here. Okay, they don't tell you the apothem, right? This one, this one, this one, they told you the apothem. They don't tell it to you this one. We can actually figure it out, all right? And it takes a little bit of doing, but we got to figure it out. So one thing that we can find without any numbers whatsoever, if I know it's a 6-sided regular hexagon or a 6-sided regular polygon, I could find that big angle right there. How do I find that big angle? Yeah, it's kind of like what we did on number 1, but this one is not 8 sides. What is it? It's 6 sides, and what is that? 60 degrees, okay? So that whole thing is 60 degrees, but why do I care about that whole thing? Tell you what, you okay if I just draw that triangle bigger? Because it's kind of a, There we go. And then there we go. All right. We good with that? So if the whole thing is 60, what's this one right here? That's 30. Okay? And if that's 30, then this is what? 60. And what don't we know? We don't know the what? The dotted line. Where's the dotted line here? It's the height or the apothem, right? The height of this thing right here is the apothem. Okay? There's this bug. It's flying around me. It's going to die in a second. All right. So we got to find the apothem. Did we mention this yesterday in the review? That, okay, well, this isn't going to be, well, is it? No. It's 30, 60, 90 is what we're going to use right here. Okay, there is one in here, I think. Isn't there? Yeah, on the last three, at least number 2, the area of the triangle, we do use Pythagorean theorem, but we don't need to use it here. Could we? Yeah, we actually could use it if we wanted to. Because, no, we can't. So anyway, are you guys listening? Pay attention. Come on. All this giggling. I know this is fun stuff, but it's not that fun. All right, so let's take a look. So let's see. We know the length of this whole thing is what? 4. So what's this little bit? 2. So what's this little bit? That's 2. Okay? All right, so this is the longer side. This is the hypotenuse. You don't have to find the hypotenuse on this one, but what if you did? What would this hypotenuse be? If it's a 30, 60, 90 triangle, the hypotenuse is how much of the short side? 2 times, so this is 4. So what's the apothem? It's 2 times what? Square root of 3. That's right. That's something that we've talked about. You got to know. All right. That's why we learned 30, 60, 90 triangles, so we could do something like that now with them. Everybody see that? Okay. So that's 2 square root of 3. So what did I just find? I just found the what? The apothem. All right. So it took a little work, right? Before they just told it to you. It didn't take any work. All right. But this one, yeah, you had to do a little bit, all right, to find that to be 2 square root of 3. That's not unreasonable for me to ask, is it? For you to do? No, because we've discussed this before. We've done 30, 60, 90 triangles. We've talked about the long side is the square root of 3 times the short side. That has to be known. All right, so that's what the apothem is. Now you can put it into the little formula. Now it's pretty easy. It's 1/2 the apothem. What's the apothem? 2 square root of 3 times the perimeter. It's what? 4 times 6. That's the perimeter, the 4 times 6, which is 24. Okay? Now you do your math. Let's do it like this. Half of 2 is 1. This is square root of 3. This is 24. So what is it? 24 times the square root of 3. That's the easiest way to do it without a calculator. I did not need a calculator at all on that, did I? All right, because really, what was the only thing? 360 divided by 6. Everybody should be able to do that, right? 36 divided by 6 is 6 with a 0. Right here, the half and the 2 cancel each other out. 4 times 6, you should know that. So you really didn't even need a calculator on number 5. You didn't have to put it into a decimal answer. If you did, it came out approximately 41.6. By the way, it is in meters, so this should be what? Meters squared. This is meters squared. Does that make sense? Either one. Okay, you don't have to have them both. Remember, we had a big talk about that, didn't we? Okay, we said you could either write it as an exact answer, which that is, or you could put it into a calculator, get a decimal answer. If you put them both, obviously it's not wrong. All right, but to me, that's the easiest one. All right, I would leave it like that if it was me. All right, there's just no reason to put it into a calculator at this point. All right, let's do another one. Number 6, we don't have to do we? Super, super easy. But you got to know stuff. You got to know the formula. If you don't know the formula, it's not easy. All right? You got to know the formula. There's nothing I can do. I could be the greatest teacher in the world, right, and explain circumference and give you a great explanation for how that works. But if you don't memorize it, right, you're not going to be able to do it. So you got to memorize it. What is the circumference of a circle? 2 pi r. There's no squared in circumference. Where is the squared? The squared is in area. Area is how many squares can you fit inside of there, right? Area is squared. Circumference is just a length. It's the distance around it, right? So there's no squared in this. Plug it in. Look, 2 times r is what? 12, 12 what? That's it. It's as easy as that is. 7's almost as easy. It's just about as easy. What's the area of a circle? What's the area of a circle? Again, you have to memorize that. There's nothing I can do for you if you don't memorize that. All right? I can teach you all night, all day long, and if you don't memorize this, you're not going to get it right. So let's do it in our head. We can do this in our head. That's the radius, correct? We got to square it. What's that? 25 times what? Pi, and that's your answer. Now let's do units. Again, I'm kind of forgetful sometimes, but this is what? Inches squared. This is what? Feet. It's not squared. Like I said, I was just testing you. Not really. I messed it up. It's just inches. All right. And this is what? Feet squared. That is. All right. Everybody good with that? All right. Now the ones that a lot of you had trouble with. All right. Some of you guys came close, but you just didn't quite get it. Will this enlarge a little bit? Yeah, let's go a little bit bigger. Okay, here we go. Let me ask you this. Number 10. I gave a couple people. Did anybody on your quiz you see it says okay? There's no check mark on it, but I did not mark it wrong. Why? Because to find the area of the segment, this stuff right here, what do? You subtract, right? So if you did this, even if you got 8 and 9 wrong, all right, that's why I just put okay and I didn't put a check mark that it was right. If you got an answer for this, an answer for this, and this answer right here was number 8 minus number 9, even if 8 and 9 were wrong, if you did that, I still gave you credit for 10 because that's how you would find the segment. Make sense? Okay. Wasn't that nice of me? Yeah. All right. You're welcome. So I guess you're one of the ones, right? Okay. So we got to find the area of the sector. What is the sector? The sector is the piece of the pie, this whole thing. Yes? Yeah. This is the easiest one. Okay. The triangle is the one that causes a little trouble. Okay. I'll give you that. The sector should not be that difficult. How much of the whole circle are we trying to find the area of? Give me how much? Give me how much? 84 degrees out of the whole circle. That's right. 84 out of what? 360. That's how much of the whole circle we're finding. In the other problem, we already knew what the equation of a circle is. What is it? Pi r squared. What is my r in this situation? It's 3. And then 3 squared, obviously, is 9. Let's just put it in here. Put a 9. Watch this. I'll show you how to do this without a calculator. You want to see? So 9 goes into 36. How many times? 4. So this is going to be what? 40. That goes, right? Let's do this. What goes into both of these?
1, 2.
Yeah, even bigger. 4 goes into both of them, right? Would you agree? Yeah, 2 does, but then you have to do it again. But 4 goes into this. 4 goes into this how many times? 10. 4 goes into this how many times? 21. That's my answer. Watch. 21 pi over 10. You could put it into a calculator. It's fine. It'll still work. You can get it right with the calculator number. All right. In fact, on my answer sheet last year, I just put in the calculator number. And then when I was grading your quizzes, I was like, you know what? I didn't put the exact answer on there. So I went through and I put the exact answer on there. So even last year, I didn't even put the exact answer. But you could. You could do this without a calculator. Agreed? You could actually do 8, 9, and 10 without a calculator. I'll show you how to do that. Now, if you wanted to put that into a calculator, I got approximately 6.6. And the units, what are my units? Centimeters. So this is area. So it is centimeters what? Squared. Same thing with that. I could put centimeters squared there. All right. What about the area of the triangle? All right. That's where it gets a little trickier. So first thing I'm going to do, we kind of did it already with that other problem. So now that you saw how to do the other problem, you should be able to see how to do this problem. So what am I going to do? I am going to, now this is not drawn here, but I'm going to draw it. Remember on the other problem, it had the dotted line? Yeah. But this one, I'm going to put that line. All right. It's not dotted, it's just red. Which one was that one? It was this one right here. See that? So if you can do this, you can do this one. All right. The thing is, it's not going to be a 30, 60, 90 triangle, but it is going to be something else that we should be able to do. All right, and I even gave you a big hint yesterday, didn't I? I said you're going to have to know how to do this kind of thing with a triangle. What did I tell you you're going to have to know how to do? Pythagorean theorem, right? I told you yesterday, right? You would have to do it. So let's do this. The whole thing's 84. So, and to tell you the truth, I don't even care what that angle is. I'm not even going to use it. It's 21, right? Or it's 22, half of it. What's that? 42. It's 42 degrees, this little bit right there, all right? Do I have a special 42-degree triangle thing that I memorized? No, I don't. So it's not really going to occur to me, but I do hit at a right angle. So I do have a right triangle. And I have this side. On that other problem that we did earlier, they didn't tell you what the length of this was, right? They told you some other length in there, all right? But what do we know about this little length? From the 4, from here to the R, what is that? It's 2, just like it was in the other problem, right? So check out what we have. I got a right triangle with 2 sides. So what can I always do to find the third side? Pythagorean theorem. Okay, so let's do that real quick. I don't know that. We'll call this our h for height. Again, what am I trying to do? I'm trying to find the area of a triangle. Now, I could go the apothem, but do I know the apothem here? No, so I'm not going to use that formula where it's 1/2 the apothem times the perimeter. All right, I could find the perimeter, right? That's 3, that's 3, that's 4, right? So that's what, 13? But I'm not going to use that because I don't know the apothem. I don't know what it is from here all the way to here. Got it? So, anyway, let's just use this one. I think I might have said that wrong. 1/2 base times the height. Okay? Do I know the base of this triangle? I do. What is it? It's 4. It's the whole triangle. We're finding the area of the whole triangle, not just the right triangle. Okay? Finding the base of the whole entire triangle, and that would be 4 times the height of the triangle. Now that's what I got to find. I got to find height. So how do I do that? Well, h squared. I'm doing Pythagorean theorem. H squared plus what? What's it? Yep. Look, here's my triangle right here. Okay? I know the 2 and I know the 3. So what is the base of this right triangle? Or it's not, I shouldn't even say base. What's the b? Right? If that's my a, this is my b, that's my c, what is it? It's 2 squared equals the c squared, which is 3 squared. So h squared plus what? 4 equals 9. H squared equals what? 5. What's h? That's a weird looking h. Square root both sides. So h is equal to the square root of 5. That's okay. I know you look at that and you're like, oh, I hate that. All right? Does anybody feel that way? Yeah, absolutely. But really, it's not that big of a deal. So look, I just write in square root of 5. Okay? If you hate the square root, you can always put it into a calculator, get a decimal out of it. But I wouldn't. I'll show you why. Look how easy it is to do the math. What's half of 4? 2. So what is the area of that triangle? 2 square root of 5. That's it. And my units, it's in centimeters, so it's centimeters squared. You can just leave it like that. I haven't even used a calculator one time yet, have I? On this whole thing. Nope. Didn't need it. Everything I could do in my head. What was the hardest thing that I had to do in my head? Maybe, how many times is 9 going to 36? Maybe that's the hardest thing I had to do the whole entire time. Okay? Now, how do I find the segment? What did I say earlier? I just subtract. That's right. I take number 8, and I'm going to use this. Okay? Because let's pretend I didn't use a calculator. Okay? I'm going to take this. I don't think anybody wrote it like, did anybody write it like this? I don't think so. But you could. Watch. Take the first one minus what? The triangle, right? Take the sector minus the triangle, and you can just leave your answer just like that. Put the units, centimeters squared. Now, if you wanted to, you could have put that into a calculator. You get around 4.5. What's 6.6 minus 4.5? 2.1. And that's how you could do it. You could do it with a calculator, or you could do it without a calculator. I know that's ugly. I know you don't like that. But I tell you what, that was a lot easier, wasn't it? Just doing it like that than having to stick it in the calculator. I mean, it's not that hard to put it into a calculator, but you never know where you could go wrong, right? You might put the wrong button for the square root. You might use the wrong number for pi. There's all kinds of ways you could go wrong on this by using a calculator. But this, it's not foolproof necessarily, but it reduces the amount of things that you could do wrong. Would you agree? Yeah. All right, you're going to have something like that on the test. The numbers might be different. All right, so don't just memorize these numbers, but memorize how to do it. All right, know how to do it. Everybody got it? We good with that? Okay. Now, let's go backwards. You want to do the middle test before the first test? You want to do the first one or the first quiz first?
Which one was harder?
I don't know. You tell me. The middle one? First one? Farther away? That kind of makes sense. Let's do that. If we have time, we'll get to the second one. So now let's do the first quiz. It's this one right here. I'm not going to hit every one because some of them are just ridiculously easy. How to find the area of this? What is it off the top of your head real quick? Which is? 50. Okay. How do you do this? 1/2 the what? Base times the height. So what's half of 8? Yeah. 4 times 12 is 48. Easy, right? What about this one? It's 1/2 the base times the height. So what's 1/2 the base? 1 times 5 is 5. Easy, right? What about this one? It's trapezoid, or it's a parallelogram, right? But they give you the height. You don't even have to figure it out. All right, so what do you just do with those two? Multiplying. What's 12 times 7? Do you know your multiplication tables? 84. Very good. All right. Look, this isn't any more difficult. It's area of a triangle. What's 1/2? You don't have to do this in your head, but half of 12 or half of 24 is 12. I don't know what that is in my head. It's 672. All right, that's 672. Parallelogram. How to find the parallelogram? Base times height. Okay, you just multiply those two together. What's 12 times 6? 72. All right, a square. One side is 2.5, 2.5. What math do I do? 2.5 times 2.5. That's right, just the base times the height. Okay, and that's 6.25. Everybody good? All right, this is a little, now that's, I bet you most of you, first day of school, walking into this room, if I gave you 1 through, 7, I bet you most of you probably could have got that, everyone right. Would you agree with that? Yeah, because that's stuff that you learned way before you came into geometry. But now, the last 3, you probably couldn't do it until we taught this stuff. All right, so here we go. You remember what the area of a rhombus is? Let's just write it right here. Area of a rhombus is 1/2 what? D1, D2. Is D diameter? Diagonals. Right, it's diagonals. Okay? So it's 1/2 times the product, right, of the diagonal. So we multiply the diagonals, take half of it. So what is this whole diagonal from here to here? It's 8. Okay, here's our 1/2. And then what's this one? It's 6. So half of 8 is 4. 4 times 6 is 24 inches squared. Okay. What's the area of a trapezoid? That's something that's a little different. You wouldn't have been able to do first day of school. Yep. So the area of a trapezoid is 1/2. It's kind of like a triangle, but you got how many bases? You got 2 bases. So it's base 1, base 2, or plus base 2, sorry, times the what? Times the height. So what do? 12 plus 22 is 34. What's half of 34? 17 times 9. I don't know what that is. It's 153. All right, so 153 meters squared. Everybody good? What's the formula? I already got it up here. What's the formula of a kite? The area of a kite? It's this one. It's the same one as the rhombus, okay? And so what are the 2 diagonals? What's the shorter diagonal? 6. And you got your 1/2. And what's the other diagonal? 8, because 2 and 6, right? So this is 2, this is 6, the whole thing is 8. 6 eighths are 48. Half of 48 is 24. That's that quiz. My goodness, if you didn't get 100 on that quiz, I don't know what. All right, that was the first quiz we took on this chapter. Here's the second quiz we took on the chapter. Still got a few minutes left. I'm trying to get done here. All right, so give me the word. We've already mentioned it once or twice today. Pythagorean theorem. Okay, and this is actually, you can actually do this without doing the Pythagorean theorem. It's called a Pythagorean triple. Okay, this is one that you could memorize. So is number 2. Do you remember? Blank 12, 13. Do you remember what it is? You could do Pythagorean theorem if you wanted to. All right, and you get it. If you don't remember, if you don't memorize the Pythagorean triples, no?
8.
Let's do the math, okay? Let's say we're taking the quiz. We can't remember them. So what do? We do Pythagorean theorem, right? So I've got what? X squared plus, what's 12 squared? 144 equals 13 squared, which is 169. That comes out to be what? 25. Square root, what's x? 5. Okay?
Wait, what is the square root of 5?
Square root of 25. Look, it's 25 I'm taking the square root of. What's the square root of 25? It's not the square root of 5. Square root of 5 is 2 point something. 5 is 5. They're completely different numbers. So don't write square root of 5. If you write square root of 5, guess what I'm doing? Bam, bam. You ever see that on your quiz? Okay. All right. What's your question? Don't. The square root of 25 is 5. Okay? I probably would not mark it wrong, but don't do it. All right, here we go. Here's another one. This is a Pythagorean triple as well, but yes. So watch. What evenly goes into both of these? What number goes into both of those evenly, I should say? 2, right? So 2 goes into this what? 3 times, into this 5 times. So if this is 3, it's a 3 blank 5. 3, 4, 5. That's one of our Pythagorean triples. But it's not a 4. What is it? It's an 8 because this is double 3, this is double 5, so this is double what? 4. 3, 4, 5. Okay? Or 6, 8, 10. Yeah? Or if you wanted, you could do Pythagorean theorem, just like we did right there. I'm not going to, but that would be 8. It's in meters. Is it squared? No, this is centimeters. All right, there you go. This one might be a little trickier. It's not one of our special triangles. So what are we going to do? Pythagorean theorem. So watch what I'm going to do. I'm going to go z squared plus, I'll write this out. I was going to do this in our head, but it might confuse you. Equals what? 7 squared. Okay? So z squared plus. Now this is easy. It looks difficult. It looks weird and crazy, but it's super easy. What happens when you square root? They go away, and then what are you left with? Just a 7. What's 7 squared? 49. Subtract 7. It's 42. Then what do? Take the square root. There you go. That's your answer. Square root of 42. It's in feet, so we put feet. Okay? All right, here we go. Classify as right, acute, or obtuse. Well, what's our rule for this? I'll show you. Sort of like that. Here's what I do. I take the c. Remember how we know Pythagorean theorem is a squared plus b squared equals c squared? I'm going to do it the other way, though. I'm going to go c squared equals a squared plus b squared. If this situation holds true, what kind of a triangle is it, if they're equal?
Equal. Right.
What kind of triangle? I've got 3 choices. These are my 3 choices. It's a right triangle. Okay, what if c squared was less than a squared plus b squared? What kind of a triangle is it? It's an acute triangle because less than, right? An acute triangle is less than what? 90 degrees, yes? Or acute angle, all right? And what if c squared was greater than a squared plus b squared? Then it's obtuse. That's what you do with these numbers, okay? You go 9 squared, you compare it to 6 squared plus 8 squared. How did I know to put 9 squared by itself? It's the longest one, right? The biggest one, okay? Put it right there. Let's see what that is. That's 81. 36 and 64 is what? 100, right? What is 81 to 100? It's less than. So what kind of a triangle is this? It's acute, and that is your answer. It also says, show your reasoning. Where's your reasoning? It's right there. That stuff right there. That's what I want to see. Don't just take a 1 in 3 chance and write down something, okay? I want to see why. You could do the same thing here. This one's obtuse if you want to try that yourself. All right, we're almost, I don't know if we'll get done this, but find the exact lengths. 45, 45, 90 triangle. So B, that's super easy. 15. Okay, it's the same. 45, 45, the 2 legs are the same. How do I find the hypotenuse without doing any math? That's it. It's just 15 times the square root of 2 for a 45, 45. Okay? This one's not 45. This is what? 30, 60, 90. Okay? The short side. They give you the short side. Okay? The easiest one is the hypotenuse. What's the hypotenuse? Yeah, we did that once today already, didn't we? Okay? This is double this. Then n is just what? Square root of 3 times the short side, or 6 square root of 3. Look, no math. Well, there's a little math involved with that. Hardly anything. No math involved with this one, or this one. Yes? All right. And then let's do this. Same kind of deal. It says AB is 10. It's a little different. It's a little harder. Okay, they ramped it up just a little bit. So if they tell you the hypotenuse this time, so how do I find the other two legs? If I knew the leg, I would multiply this by square root of 2, wouldn't I? All right, but this time I divide it. That's right. So this is 10 what? Divided by the square root of 2. But we don't leave it like this. Why don't we leave it like that? Because you have a square root on the bottom. So we call this rationalizing the denominator. So we're going to multiply top and bottom by square root of 2. Why can we do that? Because square root of 2 over square root of 2 is equal to 1. We can multiply anything by that. So what do I get? I get 10 square root of 2 over what? 2. What's square root of 2 times square root of 2? Square root of 4, which is 2. All right. What do I do with this 2? Cancels out with that 10 5 times. What's my answer? 5 square root of 2. What's CB? Do I have to go through that again? No, I know these two legs are going to be exactly the same, so I just put them exactly the same. All right? Oh, man. Time's almost out. What do they tell you here? X, Y. They tell you this is not too bad, but watch. What's the easiest one to find? If they give you the hypotenuse, what's the easiest one to find? It's not the easiest one to find. The short. This is the short one. So what is it? That's 12. So YZ is what? 12. If I know the short one, then the longer side is super easy. No math involved. What is it? That's it. And who's your favorite geometry teacher? Yeah. Mrs. Beach was my favorite geometry teacher. So that's my answer.
You're my hero.
All right. All right, there it is. Look at that. We got done every single problem. That's going to be on the test tomorrow. So be ready for it.